Hello students, welcome back to our channel Diksha Karnataka. So as you all know, your COMEDK exam is approaching. So we have discussing the previous year paper of 2023. So previous year papers are very important to understand the level of exam and the type of questions asked from a particular chapter, right? So from the paper 2023, in my previous video, I have solved the first 30 questions. As you know, there are total 60 questions. So first 30 questions is already solved. In this video, I'll be solving the next 30 questions, that is from question number 31 to question number 60. So please solve these questions on your own and then check your preparation level. You can also give your scores to yourself and post down your, you can comment down your scores also. Okay. So let us start with the first question for today. That is your question number 31. Okay, and one more thing, the PDF of this will be available in the WhatsApp channel. The link of the WhatsApp channel will be there in the description section. Please join them. So only few days are left. Please join us so that you can prepare properly for your exam. So now coming to the first question. So this question is from classification of elements and periodicity of properties. The correct order, decreasing order of negative electron gain enthalpy for these elements are given. So whenever any trend based question is asked, the first duty is to write these elements in the periodic table, their positions. Okay. So if you see carbon, okay, then we have aluminium. So here somewhere boron, below that it will be aluminium. Then we have fluorine. Okay, oxygen will come. Then we have fluorine. And I mentioned here carbon, aluminium, fluorine, oxygen and calcium. So beryllium, magnesium, calcium, right? So if you see electron gain enthalpy increases along a period. So first will be fluorine, okay, and then will be oxygen and then will be carbon. Now it decreases down the group. So next will be aluminium and then will be calcium. So the correct answer for this question will be option number A. Okay. So now let us see the next question. Question number 1 and 2 are dash. Okay. So if you see here, what we have done here is just rotated this molecule, right? This side it is same, only this molecule is rotated, a bond rotation is taken place. So whenever the different conformations that are formed by rotating the bond, that is called as conformers, right? So the correct answer for this question will be a pair of conformers, that is option number B. Next, Ti2 plus is purple while Ti4 4 plus is colorless due to. So if you see Ti2 plus, what is Ti electronic configuration? So scandium, titanium, that is 4s2, 3d2. So Ti2 plus is having the configuration of 3d2 and the Ti4 plus is having a configuration of 3d0, 4s0, right? So it is color because it has a D3, D2 configuration. This can be a correct statement. Ti4 plus has 3d2 configuration. This is incorrect. Ti2 plus is very small cation when compared to Ti2 plus and hence doesn't absorb any radiation. So I think this is Ti4 plus. So this statement is wrong. Ti4 plus will be small cation and there is no relation between the size of the cation and the absorption of radiation, right? So this is an irrelevant statement. Now there is no crystal field effect in Ti4 plus. This is also not correct. Whenever ligands will approach, splitting will take place. There is no DD transition here. Okay. So the correct answer for this question will be option number A. Next, given are H3PO2, H3PO3 and H3PO4 and H4P2O7, which of the following oxo acids result in the two series of salts? So if you have seen H3PO4, okay, so this question is from your DNF block. Okay, I'll be discussing the DNF block chapter. Many reactions, color and magnetic moment are very important topic, and this question I can say around easy level question. Okay. Next is your from P block, okay, which is your deleted portion. So, but we can discuss H3PO3 is this is like, although it is a deleted portion, but this is a question which you can attempt very easily. H3PO4 structure, if you draw, this is the structure of H3PO4, right? So it can give you two types of salt. So when the basicity is, so if one H is removed, one type of salt we will get is, see, when H3PO4 releases one H plus, we get H2PO4 minus plus H plus, right? So if Na reacts with this one, it will give us salt, that is NaH2PO4. And one more, if one more H comes from here, from your H3PO4, if two H are removed, okay, then we will get HPO4 2 minus, right? Now if Na reacts with this one, we will get another salt, that is Na2HPO4. Okay, so two types of salt we can get. So that is why the correct answer for this question is option number C. This is a very popular compound. So this question I can expect, like, even though it is a deleted portion, but it is an easy question. Next, okay, next question is from your Friedel-Crafts alkylation, that is your haloalkanes chapter. So in Friedel-Crafts alkylation reaction of phenol with chloromethane, so we have phenol, okay, and we have chloromethane, that is CH3Cl AlCl3. So we know OH, okay, so this question is from your alcohols, phenols also, haloalkanes, haloarenes, this reaction is also there. So we know phenol is a ortho para directing group. So when you add Friedel-Crafts alkylation, CH3 will come in the ortho position and in the para position. So mixture of ortho and para cresol. So this is important that we should know the common name of the compound. So OH CH3 will form. This is ortho cresol, and we will have OH and CH3 here. Right. So the correct answer for this question will be option number C. Next, which among the following is diamagnetic? So this question is from your coordination compounds. Okay. So if you see diamagnetic, NiCN4, if you check the structure of nickel, this is nickel 2 plus. So nickel 2 plus is 3D8. We have this one in 3D8, right? 1, 2, 3, 4, 5, 6, 7 and 8. Okay. And we need this is a strong field ligand, so pairing of electrons can take place. So when pairing of electron takes place, we will get this configuration 1, 2, 3 and 4, right? So this one will be used, this dsp2 hybridization will be there, 3d, 4s and 4p, right? Since here there is no unpaired electron, it is a diamagnetic compound. So the correct answer for this question will be option number A. Next, okay, this question is from your solids chapter. Okay, the deleted portion, but we can explain. NaCl has a face-centered structure with edge length of equal to 361 picometer, the radius is. So this is a direct question. The relation between this one is 4r is equal to root 2a. Okay, 4r is equal to root 2a. Now if I want to calculate r, it will be equal to root 2 by 4 into a. So we can just substitute the values, root 2 by 4, and a value is your 361 picometer. Okay, so if you solve this, the value will be coming around 127.6 picometer, that is option number A. Okay, now let us see the next question. Which one of the following is an important component of chlorophyll? So this question is again from your biomolecules. Okay, so chlorophyll contains an important pigment, that is magnesium. So correct answer for this question will be option number B. This is an easy question. Okay, next, the order of acidic strength of boron trihalides. This is also from your group 13. Okay, this question is important one. Please listen here. What is the acidic nature depends on? What do you mean by acidic property? Acidic property means the tendency, okay, tendency to accept electrons. Tendency to accept electrons is called as this one, acidic nature, right? Now boron is a family which is having, boron has always electron deficient, so it can accept the electrons. Now what happens here is a special case, you have to understand. BF3, okay, if I draw the structure of BF3, okay, and here is the vacant orbital of boron. Now what happens in case of fluorine, because of the same or the small size of fluorine, there is a, like what I can say, the orbitals of boron and fluorine are of similar size. So what happens, the lone pairs of the fluorines can be donated to this one, right? So if this is donated here, the urge to get electrons is satisfied here. So it cannot show any acidic character further, because it is internally, it is getting electrons from the fluorine. So the acidic character here will be less for BF3, then BCl3, BBr3, Bi3. So the correct answer for this question will be option number B. Okay, I hope this concept is clear. So acidic strength BF3 will be less because it doesn't want more electrons, because already its orbital is filled with the fluorine because of the same overlapping or same size. Now if you consider Bi3, okay, so if I drew Bi3, okay, the overlapping is not there. Okay, the lone pairs of I cannot be donated here. So this boron is thirsty for electrons. Okay, it is having hunger for more electrons. So it will show acidic character from outside. Wherever it is getting electron, it will take. But this one is not hungry because its electron deficiency is satisfied by the overlapping or the back bonding from fluorine. Okay, so like that you can understand. Next, a volatile compound is formed by carbon monoxide and, so if you know nickel is there, if you treat it with 4CO, we will get NiCO4, which is a volatile compound, right? So the correct answer for this question is option number C. So this question is also from coordination compound. Next. So next question is also from coordination compound. The compound PtCl2En2 2 plus ion shows. So if you draw this one, we can have cis and trans. If I draw trans, this is the trans form, and if we draw the cis form will be right. So this is first they are showing geometrical form, and the cis form can also show optical isomerism. If you draw the mirror image, they will be non-superimposable. So this shows both geometrical and optical isomerism. So correct answer is option number D. Next, 15 gram of calcium carbonate completely reacts with. Okay, so this question is from your some basic concepts of chemistry, that is your first chapter. Okay, so this is also very easy question. You know what is happening here? The reaction is between CaCO3 plus HCl. Okay, this gives you CaCl2 plus H2CO3, right? So if you like balance it, we'll require 2 HCl, right? Now, if you take the molar masses, calcium carbonate is 100 gram and this one is 35.5 plus 1, 36.5, 36.5 into 2 is 73 gram, right? So now if you solve this, what I can get is 100 grams of calcium carbonate reacts with 73 gram of HCl, right? Then 1 gram will react with how much? 73 by 100. And we have this one 15 gram, right? So 15 gram will react with 73 by 100 into 15. So we can just solve this 0.73 into 15. So 15 3s are 45. Then we'll have, so once you solve this, we'll get around 10.95 gram of HCl. Okay, so the correct answer for this question will be option number B. Okay, now let us see the next one. The behavior of real gases approach the ideal behavior. So this one is actually from your states of matter chapter. Okay, ideal gas and real gas. Okay, states of matter chapter is there. So approaches ideal behavior at. So whenever there is high temperature and low pressure, the real gas starts behaving as ideal gas, because at low pressure the force of attraction will be less, and high temperature also the gases will be far away and the intermolecular forces of attraction can be considered to be negligible. So the correct answer for this question is option number B. Next, Bohr's radius of second orbit of B3 plus is equal to. Okay, so this is very easy question. This question is from your structure of atom chapter. Easy question. Okay, first of all, what is the general formula for any radius? Rn is equal to 0.53 n square by z. Okay, so for Be3 plus, for R of Be, we will have 0.53 into n square. N means the orbit number. So second orbit, that is your 4. 2 square it will be, like 2 square divided by Z. Hydrogen, helium, lithium, beryllium. So Z value for beryllium is 4. So this 4 will get cancelled, that is 0.53. Now you can check all the options where this ratio, okay, n square by Z. If n square by Z is equal to 1, then it will be equal to beryllium radius. So we'll check for option number A. What is n square by Z here? N square is 4 and Z value is 1. So this ratio is coming 4. So this cannot be the answer. Now for second one, n square is 2 square, that is 4. And Z value is again 2, hydrogen, helium. So this is equal to 2. So this cannot be the answer. Next, we have third orbit of lithium 2 plus. So hydrogen, helium, lithium. Lithium square, that is 3 square by 3. So that is equal to again 3. So this also cannot be the answer. The last one, first orbit of hydrogen. So 1 square by 1, that is equal to 1. So this ratio is coming as n square by Z. So the correct answer for this question will be option number D. Next, how much faster would a reaction proceed at 25 degrees Celsius than at 0 degrees Celsius if the activation energy is given? So this question is from your chemical kinetics, right? This is also a high weightage topic. So prepare this Arrhenius equation, first order, zeroth order laws, rate law, integrated law, differential rate law, catalyst are all very important topics. Okay, now if you come this one, we have this formula, log of K2 by K1 is equal to EA by 2.303 R into 1 by T1 minus 1 by T2. Okay, so now if you solve this one, we will get here EA value is given 65 into 10 to the power of 3. Here we have 2.303 and 8.314. Now if you solve this one, here we will get 1 by T1, like 1 by T1 is 0 degree, that is your 273 Kelvin minus 1 by 290, sorry, minus 1 by 298, right? So if we solve this value, we'll get 65 into 10 to the power of 3 into this one 298 minus 273, right? That is nothing but equal to 25. Then divided by 2.303 into 8.314 into 273 into 298. So this one will have a little big calculation. Some questions you have to save time and use in this type of questions to invest for calculation. So this ratio will be coming around 1, okay, 1.04 something will get. So I can say log of K2 by K1 is equal to 1.0 something. So K2 by K1 will be equal to 10 to the power of 1, that is equal to 10 times, right? So the rate increases by 10 times, okay? So the correct answer for this question will be option number D, that is 10 times. Next, the blue coloration obtained from Lazine test of nitrogen is due to the formation of. So this is also from your P block, okay? But this one is also there in your salt analysis and all, Prussian blue formation. So that's why you can expect this question. So that is due to the formation of your Fe4, FeCN6 3 minus, okay? So the correct answer for this question is option number A, okay? So next question. So now let us see the next question. The ion that is isoelectronic with CO, okay? So the ion that is isoelectronic with CO, okay? So isoelectronic means it should have same number of electrons. So this question it can be from your chemical bonding, okay? We know these structures. Now we can just calculate the number of electrons. Carbon has 6 electrons, oxygen has 8 electrons. So in CO there is 14 electrons, right? Now if you check here, O2, 8 plus 8, 16 plus 1 means total electrons is 15. So this cannot be the answer. Carbon has 6, nitrogen 7, 13 plus 1, 14. So this can be there. O2, again 8 plus 8, 16 plus 1, that is 17. This cannot be answer. N2 is 7 plus 7, 14. Minus 1, that is 13. This cannot be answer. So the correct answer for this question is option number B. Next, question number 48. At 300 Kelvin, the half-life period. Okay, so again we have chemical kinetics question. Very important topic, chemical kinetics. At 300 Kelvin, the half-life period of a gaseous reaction at initial pressure of 40 kilopascal is 350 seconds. And when the pressure is 20 kilopascal, the half-life period is 175 seconds. The order of the reaction. Very important question, this one. So you have to remember a formula, T half of 1 by T half of second is equal to P2 by P1 to the power of n minus 1. Okay. This one can also be in terms of concentration also. For this question, I have taken P2 by P1. You can also take concentration. So what is this? Actually, this formula comes from here. That is T half of anything is inversely proportional to the concentration to the power of n minus 1. Right. So now let us write the data here. What is the data given? At 40 kilopascal, what is the time? Time is 350 seconds. Half-life is 350 seconds. And at 20 kilopascal, this one is half-life is 175 seconds. So we can substitute here first T half of 1. So T half of 1 is 350. Then T half of 2 is 175. This is equal to P2. Means with this one, P2 we have to put. That is 20 kilopascal by 40 kilopascal to the power of n minus 1. So now if you solve this, we'll get 2 and 1 by 2 to the power of n minus 1. So I can write 2 is equal to 2 to the power of 1 minus n. Now if the bases are same, we can equate it. So we'll get 1 minus n is equal to 1. So n will be equal to 0. So the correct answer for this question is option number D. Okay, I hope this is visible. Next, question number 49. If 2 moles of C2H6 are completely burnt, okay, so from we get a question from thermodynamics. This is also a moderate weightage topic. You can get two questions you can get from this chapter. Okay, so if 2 moles of C2H6 gas are completely burnt, 4,100 kilojoule of heat is liberated. 2 moles of C2H6, right? So let us first burn this one, C2H6 and O2, and let us see what is the product formed here. So burnt means it is the combustion reaction. Reaction is with oxygen. Okay, so you don't have to go and burn it right now. Okay, so C2H6 plus O2 gives you CO2 plus H2O, right? So now let us balance it. Here 2 carbon, so we'll have 2 carbon here. Sorry, there's 2 moles of C2H6, right? So we will have 4 moles of carbon dioxide. Now here it is 12, so here we will have 12, right? 6H2. Okay, 1 second, we'll write it properly. So here we have to just balance the equation. We got here 4 carbon, so 4 carbon and 6 to the 12, 12 means 6 hydrogen. So now if you see, you have 8 plus 6, 14 oxygen, so 7 O2, right? Now the question is telling you, if 2 moles of this is burnt, we are getting this much energy, or the enthalpy of combustion is 4,100 kilojoule. If delta H for CO2 and O2 and H2 are given to you, then what is the enthalpy of formation of C2H6? Very easy question. If you know the reaction, what is the general formula? Delta H of any reaction is equal to delta H formation of products minus delta H formation of reactants, right? So now if I write delta H of reaction is equal to delta H formation of products. What are the products here? 4 times of CO2, right, plus and 6 times of water, 6 times of delta H of water. Okay, then minus O2 enthalpy of formation is considered to be 0. So now if you put this one, we will get 2 times of delta H of formation of C2H6, right? So we got all the values. Now this value is given 4,100 kilojoules, but you have to remember that energy is liberated is mentioned, right? So you must take it as minus 4,100 is equal to 4 into carbon dioxide is minus 410 plus 6 times into minus 285, okay, and then equal to 2 times of delta H of C2H6, right? So now you solve this value, C2H6 value, you can solve it. The answer you will be getting around is minus 375 kilojoules. This simple multiplication and addition calculation is there. You need to give little time in this question. So the correct answer for this question will be option number B. Next, abnormal colligative properties are observed. So this question is from your solutions chapter. So are observed when the dissolved non-volatile solute in a given dilute solution associates or dissociates, right? That is where the Van 't Hoff factors come. So the correct answer for this question is option number C. Next, aqueous copper sulfate changes its color from sky blue to deep blue on addition of NH3 because. Okay, so this one is again the question from coordination compounds. So what happens here is when you have copper sulfate aqueous one, okay, and you put some NH3, okay, so there is a complex, a new complex is formed where you get CuNH3. Okay, this complex NH3 replaces all the water molecules here. So the correct answer here is CuH2O whole 4 2 plus is labile complex. Labile complex means the complexes from where the ligands can be removed easily. Okay, labile complex and changes to CuNH3 whole 4 2 plus as NH3 is a stronger ligand than H2O. So whenever we add a stronger ligand, it can replace the weaker ligands to give you a new compound. Okay, so that is why the correct answer for this question will be option number C. Okay, next question is from your organic chemistry. You have to identify A, B and C. So we have been given with this one, okay, CH2Br and this one reacts with ETOH, I am writing, okay. SN2 mechanism. In SN2 mechanism, what happens? There is no formation of carbocation. Directly, there will be replacement of the bromine group. So, what I will get? CH2OET or CH2CH3, right? So, my A will be your, this one will be there. Here it will be OCH2CH3. So, this can be the answer. This one is wrong. Okay, here A, B is given. Okay, the options are little incorrect here. Okay, let us discuss the answers here. Okay, so this one A can be there. This one is wrong because here methyl group is there. So we can eliminate this option. So A is this one. Now if you see B, in B what happens? There is SN1 reaction. SN1 reaction follows your carbocation is formed. So there is a possibility of rearrangement here. So when this one Br leaves, okay. So I'll draw now for B. The intermediate formed here is C. This is the carbocation formed here, right? Now this carbocation is a primary carbocation, but if we do a methyl shift here, we will get a tertiary carbocation. So that is why what happens here, we get a shifting and we get methyl carbocation, right? So here there will be CH3 group and here the plus charge is formed. Now this one can take a nucleophile, that is OC2H5, to give the compound like this. Right, so this is the, again this is your B product. Now elimination, if you have to eliminate it, what will happen? Water molecules will be removed, so we can have one H here. So I'll erase this A product. Okay, so if we see here, for A, after getting B, if we do eliminations, then the product formed here will be okay, let us draw it again here. We'll have this one C, 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 and here we have this C, and here we have C, here it is H, and here we have O, CH2, CH3. So when you do heating, the elimination will take place and this part will go out and we will get here a double bond. Okay, so the correct answer for this question will be your option number A. Okay, all the products are same here. So these options may be, but you can just prepare the mechanism and identify the products. Next, decomposition of hydrogen peroxide can be prevented by adding. So this question is again from your P block oxygen family. So you can remember, by adding urea, we can stop the decomposition of H2O2. Correct answer is option number A. Okay, next question is again from chemical kinetics. For a reaction 2A plus B gives you product if the concentration of B is kept constant, okay, and the concentration of A is double, then the reaction rate is, okay. So whenever such reactions are given where there is nothing mentioned about the order and it is a one-step reaction, for such type of reactions we can write rate is equal to K A to the power of 2 and B. Okay, this is not possible every time. We cannot say every time the coefficient will be equal to the order, but since it is a one-step reaction and nothing is mentioned in the question, we can take it in this way. So now if the A is doubled, okay, so I'll get K 2A square, okay, B is still constant, R dash, right? So now if you take the ratio of these two, I'll get what? This one we can written as K 4A square and B. So if I divide R dash by R, I'll get 4, right? So the new rate is 4 times the initial rate. So the correct answer will be quadrupled. That is option number B. Next. So this question is from thermodynamics. You can see how easy questions are asked in adiabatic changes. We know in adiabatic process, delta Q or Q, no heat exchange take place. Q is equal to 0. So the correct answer for this question is option number A. Next, question number 56. This is from your again coordination, DNF block, where you have to prepare properly Cr2O7 2 minus and MnO4 minus. These two are important compounds. Their reactions, their oxidizing properties, their methods of preparation, structure. Please prepare. These two are important. Next, in dilute alkaline solution, you know MnO4 reacts in 3 different medium in different differently in different medium like alkaline, neutral, and acidic medium. So in this one, MnO4 minus in alkaline medium gets converted to MnO4 2 minus. Okay, so here it is 2 minus. Okay, The correct answer for this question will be option number B. And in the acidic medium, what happens? In acidic medium, it gets converted to Mn2 plus. And in neutral medium, it gets converted to MnO2. Okay. So the correct answer for this question will be option number B. So this is in basic medium, this is in acidic medium, and this is in neutral medium. Okay, next, which of the following complexes will show optical isomerism? So whenever there is like chelating ligands are there, they will always form your like cis form of the chelating ligands will give you optical isomerism. So you can see here En is a chelating ligand, OX is a chelating ligand, again En is a chelating ligand here, and NH3 and whole 4 will not show. So the correct answer for this question will be option number A, that is 1, 2 and 3. So if you just see here, I'll draw small like shortly. COCl2 we can draw like this, NH3 En. Okay, so this will have an optical isomerism. Then if you draw CrCl2 oxalate, so we have CrCl oxalate. Okay, this one can also be there. And then cis CuEn2Cl2. So if you draw like this, okay, this one can also show. These three will show optical isomerism. So correct answer for this question will be option number A. Next, OH PBr3 alcoholic KOH. So when you treat OH with PBr3, so this is not benzene, sorry, it is cyclohexane. Okay, so we don't need to draw this one. Okay, now OH with PBr3 will give us what? Br, right? Now if you do alcoholic KOH, it will do elimination and will get a double bond here. So the correct answer for this question is option number A. Okay, next. The ratio of the average velocity of a gas molecule to the root mean square velocity at a particular temperature is. So this is also from your deleted portion, that is your kinetic theory of gases, right, from that chapter. So if you know the formula of mu average is 8RT by pi m root over, and mu RMS is equal to root over of 3RT by m. Okay. So now if you take the ratio of both of this, we'll be getting around 1:1.81. Correct answer for this question will be option number A. Okay. Next, more salt has the formula of. Okay, so this is again from your coordination compounds. We have double salt examples there, and this is also very commonly used in your practicals. So you should know the structure. So the structure is your FeSO4. So we will have, there is NH4 and so we can eliminate these two. Fe is there, two sulfate groups are there, and one NH4 group is there, right? So this one is also incorrect. So correct answer for this question is option number B. Okay, yes. So these were the, like, we have completed chemistry previous year question of 2023, all the 60 questions I have discussed. So your task is now to download the question paper, learn the practice these questions again, and understand the level of your preparation. If you have any doubt in any question, there are some deleted portion questions, so just leave them. If you have any doubt in any question that we are solving, just comment it down. I'll be discussing it in my next video if any concept you require to be revised. And I want you to just type the score of this and try to do with score so that you can just analyze where you are standing in between now. Okay, so that's all for this video. If you have found this video useful, please like, share and subscribe our channel. So many more videos will be coming for your COMEDK preparation. So all the best. Thank you.